All right, so get this. We are diving deep into the world of serverless data engineering today.
Oh, wow.
Specifically, how we can use a language like Rust to optimize those AWS Lambda functions
Okay.
that you've probably heard about.
Yeah.
And to help us navigate this whole thing, we have an absolute pro joining
It's
us.
awesome.
Someone who's not only been coding for over 2 decades,
Wow.
but has also taught this stuff at universities like UC Davis and Northwestern.
Yeah. I mean, what I find really exciting here is how we can use some really cutting-edge tech to actually save money in the long run.
Right.
Building something cool is great, but building something cool that's also smart and cost-effective,
Yeah,
that's really the sweet spot.
couldn't agree more. Okay, so before we get ahead of ourselves, let's break down this whole serverless thing for our listeners.
Yeah,
Because it is one of those buzzwords you hear everywhere.
it is.
How would you explain it to someone who's maybe never even heard of it?
So imagine your house lights, right?
Okay.
Like, it would be a huge waste to have them on 24/7. Serverless functions are kind of similar. They only turn on when something triggers them, like a motion sensor light.
Right.
This makes them crazy efficient for, very specific tasks.
Okay. I'm seeing the light, so to speak.
Ah.
So instead of having servers constantly running, we're talking about using computer power only when we need it.
Exactly. And that, like, on-demand aspect of serverless
Yeah.
is a big reason why it's so appealing for data engineering.
Okay.
It's all about, speed, scalability, and yes, keeping those costs down.
That makes a ton of sense.
Yeah.
Now, we also have Rust in the mix here.
Yeah,
I know it's a powerful programming language,
it is.
but it also has this reputation for being, well, a bit tougher to learn.
Yeah.
What's the deal with Rust, and why is it such a good fit for serverless?
Okay, picture this. You can build a disposable cup right quick and easy.
Okay.
Or you can take the time to craft a really durable, long-lasting one.
Okay.
Python, which we all know and love, is like that disposable cup.
Yeah.
Very convenient, but maybe not the most robust in the long run. Rust, on the other hand, is like taking the time to craft something that will last, something that will pay off with better performance,
Right.
safety, resource efficiency in the long run.
I love that comparison.
Yeah.
So with Rust, it's more about the upfront investment, but then you save on things like maintenance resource usage.
Exactly.
Like you're avoiding those late night debugging sessions because you just built it right the first time.
It's true. And it's like,
Yeah.
build once, wash thousands of times.
Right.
And with serverless functions constantly being triggered,
Yeah.
that initial effort with Rust starts to look really, really good.
Yeah, because those small efficiencies at scale really start to add up.
Totally.
That's like the difference between making coffee at home every day versus going to a cafe every day.
It's true.
Those small savings really do add up over time.
Absolutely. So, we've been talking about serverless. Let's introduce the 800-pound gorilla in the room,
Yes.
AWS Lambda. This is basically a platform where you can run these code snippets, these serverless functions, without having to deal with the headache of managing servers yourself.
So AWS Lambda is like the engine that powers our serverless functions.
That's a great way to put it.
Okay.
And it pairs really well with Rust.
Right.
Remember all that talk about efficiency?
Yeah.
Well, Lambda charges you based on how much compute time and memory your code uses.
Okay.
And since Rust is known for being super fast
Right.
and having a very minimal footprint, it can lead to some really serious cost savings.
Yeah, it's like swapping your gas guzzler for an electric car.
Yeah.
You save money on fuel and reduce your carbon footprint.
Yeah.
Similarly, Rust's efficiency can significantly reduce your AWS Lambda costs,
Exactly.
especially at scale.
Yeah.
I'm really starting to see why this is such a powerful combination.
Yeah. And to make this whole Rust on Lambda experience even smoother, we have something called Cargo Lambda.
Oh.
Think of it as your trusty serverless toolkit. It helps streamline that entire process from writing the code to actually deploying it on AWS Lambda.
So let me get this straight with serverless. We're only using resources when we actually need them.
Yep.
We have Rust, which is squeezing every ounce of performance out of those resources.
Yes.
And then finally, Cargo Lambda swoops in to make the whole process a breeze.
You got it.
All right,
So are you ready to see how this plays out in a real-world scenario?
let's do it.
Yeah.
I am ready to see what this combo can do.
So to actually see this in action, our expert built a simple game using AWS Lambda, and he tested it with 4 different languages: Python, Ruby, Node.js,
Oh, okay.
and of course Rust.
I am hooked. What is this game?
It's called the tunnel game.
The tonal game. Okay.
It's pretty straightforward, actually. You send a message to the Lambda function if your message contains the word echo.
okay.
It responds with either dark echo or light echo.
Yeah.
If not, it just tells you to say echo to play the game.
So it's like shouting into a tunnel and seeing what comes back.
Exactly.
I kind of love it.
It's a fun way to illustrate how these different languages perform differently in a serverless environment.
Right.
And the key things we are looking at here are memory usage
Okay.
and execution time.
Makes sense.
Those are the factors that directly affect your AWS Lambda cost.
Right, because at the end of the day, it's about being efficient with our resources.
100%. And the results were interesting. Rust consistently outperformed the other languages across the board.
Wow.
We're talking like significantly lower memory consumption
Okay.
and much faster execution times.
So it's not just milliseconds here or there.
Mm-hmm.
It's like the compounding effect that it has on your bottom line.
Precisely.
It's like choosing the express lane at the grocery store. It might seem like a small time saver, but those minutes add up.
Yeah.
Especially if you're doing it every week.
Exactly. And to understand like why Rust achieves this level of performance, we have to look at how it manages memory.
Okay.
Unlike garbage-collected languages like Python or Ruby, Rust uses a system of ownership and borrowing.
Hold on. Can we break down that ownership and borrowing thing a little more?
Sure.
It sounds like a key concept.
Yeah, so think of it this way. Imagine you have a really valuable book.
Okay.
In Python, it's like making copies of that book for everyone who wants to read it.
Okay.
That takes up a lot of space, right?
Yeah.
But in Rust, it's like saying, hey, you can borrow this book,
Okay.
but you have to give it back to me when you're done.
Okay.
This system of lending and returning means that Rust uses memory much more efficiently because it's not creating all these unnecessary copies.
Okay, that makes sense. So less memory overhead equals lower cost and faster execution.
Exactly.
It's like having a super efficient engine under the hood.
Yeah, like a Formula One car versus a minivan.
Okay.
And that efficiency is crucial in a serverless environment where resources are often limited.
Right.
And we need those like lightning fast responses.
Right. It's about squeezing every ounce of performance out of what we have.
Exactly.
This all sounds amazing, but I have to ask, isn't Rust supposed to be this really complex language to learn?
Yeah, you might be thinking Rust sounds really powerful, but is it worth the learning curve?
Yeah.
It's true. Rust has a steeper learning curve than Python.
Okay.
But this is where its elegance shines. Rust's compiler, although strict, acts like a very helpful guide.
Okay.
It catches errors early on, and it forces you to write cleaner, more efficient code.
So it's more like an upfront investment in learning the rules of the road.
Yeah.
Once you've mastered them, you can drive with more confidence and control,
Exactly.
knowing that you're less likely to crash.
And the payoff in terms of, performance cost savings
Right.
and just the satisfaction of building really robust applications is well worth that initial effort.
Totally.
Plus, there are all these great tools like Cargo Lambda, which we talked about earlier,
Right.
that make that whole development and deployment process much smoother.
It's like investing in a good set of tools. They might take a bit longer to master,
Right.
but ultimately they make you a much more efficient and skilled builder
100%.
in the long run.
Now, while we've been focusing on AWS Lambda,
Yes.
it's important to remember that these concepts apply way beyond just this one platform.
So this isn't just about AWS. It's about changing how we think about building and deploying software in general.
Yes.
It's about applying these principles of serverless design and resource optimization to a whole range of challenges.
Exactly. Serverless computing, especially when you combine it with a language like Rust,
Yeah.
has the potential to revolutionize so many different areas. It's really exciting.
It's like we've unlocked this secret level of efficiency, and now we have this whole world of possibilities to explore.
Precisely, and that's the beauty of it. Speaking of exploring possibilities, as we start to wrap up this deep dive, I want to leave you with a final thought-provoking question.
All right, hit me with that thought-provoking question.
So we've seen how well Rust performs in the serverless world, especially with AWS Lambda, but what about other cloud platforms? Or even completely different use cases? Where else could we apply these principles of serverless design and resource optimization to make a real impact?
Yeah, it's like we've stumbled upon this blueprint for efficiency, and now we can use it to build all sorts of amazing things.
Exactly, and that's what makes this so exciting. The knowledge we've talked about today isn't limited to just one platform or use case.
Right.
It's a starting point for innovation, for
Right.
questioning those old ways of doing things, and for pushing the boundaries of what's possible in data engineering.
So to our listener out there, here's a challenge for you. You take these insights, experiment, explore, and see where else you can use the power of serverless and Rust to build something truly remarkable. Who knows, maybe you'll be the one teaching us about your groundbreaking discoveries in the future.
I wouldn't be surprised there's a whole universe of possibilities out there.
This has been an incredible deep dive. A
Mhm.
huge thank you to our expert for sharing such incredible knowledge and insights with us today.
It was my pleasure.
And to you, dear listener, thank you for joining us on this journey of discovery. Until next time, keep exploring, keep learning, and keep diving deep into this fascinating world of tech.